Hello, everyone. So today we are going to continue reading our Magic School Bus Electric Storm book, and we are going to start on chapter 4. So we're going to pick up where we left off. All right. The bus began to whip around inside the cloud. It was flipping all around. So this is what it's like to have our heads in the cloud, said Carlos. Our heads and the rest of us too, said Arnold. I can't tell which way is up. Neither could I. The wind inside that cloud was strong. The tiny water droplets that formed our cloud were churning around, and so were we. Winds have their way of moving water droplets around inside clouds, Miss Frizzle told us, and that can make a cloud change in a hurry. So right here is a little info cue note. And it says, Taking Sides by Ralphie. Air inside developing thunderclouds move in a pattern. Updrafts of warm, expanding air rises up on one side of the cloud. We call this the updraft side of the cloud. As the air cools, it gets heavier and moves down the other side of the cloud. This is the downdraft side of the cloud. So when warm air pushes up, so the updraft of warm expands to one side. And as it cools down and gets heavier, it moves down the other side. So that's pretty cool to know. Anyway, wind pushed the churning water droplets of the cloud higher every second. The magic school bus flew up and down. Arnold was holding his arms high over his stomach, trying to stop it from flipping. Does this bus come equipped with motion sickness bags? He asked. Water droplets collide all around us, forming bigger and bigger drops. Before we knew it, plenty of droplets were large enough and heavy enough to fall from the cloud as rain. I don't see any lightning yet, but this is definitely starting to feel like a storm, said Ralphie. This was good news for the drought, and bad news for us. At least that's what I thought, but Charlie was grinning from ear to ear. I knew it was going to storm, he said. He looked over his shoulder at D.A.'s notebook. Now I know why. The water vapor that makes my hair frizz moves up into the atmosphere with the hot air. He snapped his fingers. Next thing you know, there's a storm cloud. Actually, this air doesn't feel so hot anymore, I said, rubbing my arms. Who turned on the air conditioning? Mother Nature did, Miss Frizzle answered. Charlie looked really confused to hear that. I don't remember learning anything about her in my meteorology class, he said. I thought our cloud was moving up because the air around us is warm, Tim added. It is, D.A. told him. She showed him a page in her weather book, but the air outside our cloud gets cooler as we travel higher in the atmosphere. Sooner or later, the air inside the cloud cools down too. Right you are, D.A., said Miss Frizzle. The winds inside our clouds have stretched the cloud up so high that the air temperature at the top of the cloud is below freezing. That's really cold. The goosebumps on my arms told me she was right. So did the ice crystals I saw forming in the cool air outside the bus. Now, water droplets and ice crystals flew all around us inside that cloud. They were like high-speed bumper cars that slammed into one another. In no time at all, the magic school bus was covered with water all over again. Then we banged into an ice crystal and, hey, we froze right onto the surface of the ice, said Tim. We're definitely not a calm, puffy cumulus cloud anymore, Wanda said. Not with all this rain, hail, and crazy wind. So here's another little cue card over here. And then here's the picture of the magic school bus stuck to the big piece of ice. So I'll read those sound bubbles or thought bubbles after I read the cue card, okay? So it says, Presto Changeo. It's Hail by Tim. Hail forms when ice crystal bumps into very cold droplets of water. The water freezes onto the surface of the ice, coating it with new layers of ice. More and more layers of ice form. Eventually, the hail becomes too heavy and it falls. And then, so our thought bubbles say, why, this is one chilling adventure. And somebody else says, I wish I'd stay home today, where it's warm. And there is a lot of ice on the bus. I don't know if you guys can see that. Okay. No kidding. In no time at all, our cloud had blown to a huge, towering shape. The wind was so strong it swept the top of the cloud flat. Taking a look at Miss Frizzle's cloud chart, I realized exactly what kind of cloud we had became. We were a I know how to say this. This is sad, guys. A cumulonimbus cloud. Oh, sorry. All right, and here's another cue card. Mother Nature Grows Big and Tall by Phoebe. Did you know that cumulonimbus clouds can reach heights of more than 50,000 feet? That's more than 9 miles, 15 kilometers high. Hailstones are usually about 2/10 to 4/10 inch, 5 to 10 millimeters in diameter, but hailstones are as large as 5.5 inches, 140 millimeters across, have been seen. Whoa! Carlos grabbed into the seat in front of him as the bus lurched on a strong updraft. Miss Frizzle, I'm feeling all shook up, he said. Miss Frizzle's eyes sparked. When ice crystals and water droplets collide inside thunderclouds, they do a lot more than just shake things up. They provide just the right ingredients for thunder and lightning to make an electrifying entrance. We, TV personality, knows how important it is to make a good first impression, Charlie said. Then he gave Miss Frizzle a sheepish grin and added, I guess you're talking about a different kind of electricity, though, huh? You're catching my drift, Mr. Nimbus, said the Frizz. Class, get ready for some high voltage action. Things are about to charge up in a big way. So, here's another little cue card I'll read you guys. Clouds Change Fast by Tim. Winds inside a cloud, speeding upward on the updraft side and sinking fast on the downdraft side, can change the shape of the cloud super fast. A puffy cumulus cloud can turn into a towering cumulonimbus storm cloud in as little as 30 minutes. That's not surprising considering how fast winds can travel inside cumulonimbus clouds, more than 50 miles, 80 kilometers per hour. Chapter 5. Arnold scrunched down as far as he could in his seat. I'm not ready for this, he said. Not by a long shot. I couldn't blame him. I was pretty nervous myself. Did you say charge up, Miss Frizzle? I asked. Sure, D.A. said. After all, lightning is electricity, isn't it, Miss Frizzle? You said it, the Frizz told her. When ice crystals and water droplets bump against one another in thunderclouds, a kind of energy called static electricity builds up. Where? Where? Charlie asked. He turned his head in a million different directions. You can't always see static electricity. D.A. handed him her notebook. But you can read about it in my notes, she said. Charlie started reading right away. I guess he didn't realize Miss Frizzle's way of teaching goes a lot further than just getting information from books. I'd started to like Charlie, and I felt sorry for him. He wanted to be a weather forecaster so badly, but he really didn't know much about weather. Let's find some static electricity in action, shall we? Miss Frizzle said. She opened the bus door. The next thing I knew, the wind moving inside the clouds sucked us all right out of the bus. All of a sudden, our clothes were covered by protective suits. They were kind of like the suits firefighters wear, with padding, goggles, and helmets. Not that I was complaining. That way we were blowing around inside that cloud. We really needed protection. We're getting smaller again, D.A. said, holding on tight to her book about weather, a lot smaller. Perfect, said Miss Frizzle. Shrinking down to electron size is key to learning about static electricity. I wasn't sure what she was talking about, but I did know one thing. Being microscopic sure made the world look different. I didn't see water droplets and ice crystals anymore. Instead, we were surrounded by, to tell you the truth, I didn't know what to call the things I saw. Class, these are the atoms that make up ice crystals that we're in, Miss Frizzle explained. Wow, I said. Those atoms were amazing. They were like balls of protons and neutrons with with electrons zipping all around them. I couldn't take my eyes off of them. Then I saw a knot of protons and neutrons floating in the air on its own. Charlie noticed it too. He stared at the protons and neutrons, frowning. Then he looked in DA's notebook. And then it says right here, from the desk of Miss Frizzle. It says, what makes an atom? Atoms are made of smaller particles called protons, neutrons, and electrons. Electrons contain a negative electric charge. Protons contain a positive electric charge. Neutrons don't have any charge. The protons make neutrons group together to make the nucleus. So, right there. Why doesn't that atom have any electrons? He asked. Before Miss Frizzle could answer, something really weird happened. We started orbiting around the protons and neutrons. Whoa, Tim said as we zipped around and around the center of the atom. Does this mean we're the electrons? Wanda finished. Right you are, said Miss Frizzle. Usually an atom contains an equal number of protons and electrons. DA nodded. According to my research, the positive charge of protons balances out the negative charge of electrons, so that the whole atom doesn't have any electric charge. So true, Miss Frizzle said. But sometimes atoms bump into one another, like the atoms of water droplets and ice crystals that keep crashing together inside our cumulonimbus cloud, Ralphie said. The Frizz grinned from ear to ear. You get the picture, Ralphie, she said. When atoms collide, electrons from one atom can rub onto another atom with electric results. We didn't have to wait long to see for ourselves what she was talking about. Yikes! Incoming atoms, Ralphie announced. Atoms zoomed toward us from all directions. And here's another cue card, little fact note. It says from DA's notebook, charge it. When electrons are transformed from one atom to another, atoms can end up with more or fewer electrons than they normally have. An atom with more electrons than usual has a negative electric charge. An atom with fewer electrons than usual has a positive electric charge. Atoms that have a charge have static electricity. And then there's a picture here of Miss Frizzle saying we're all charged up, with all the kids floating around with all the atoms and the neutrons and the electrons. Pretty cool. Wham! An atom hit us. It was part of a hailstone. It zoomed off again in a flash, taking Wanda, Tim, and Ralphie with it. Oh no, I shouted, watching my friends orbit around with electrons of the other atom. Don't look now, here comes some more, Arnold said. Wham! Bang! 2 more atoms smashed onto us. They were part of a large raindrop. Electrons were everywhere. The 2 atoms bounced away fast. This time, I felt myself being pulled along with one of them. D.A., Phoebe, and Arnold came right along with me. Here we go, D.A. said. Looking back, I saw that Carlos and Miss Frizzle had rubbed off onto the second atom. I sure get a charge out of being in a thundercloud, yelled Carlos. We all groaned. Carlos! This was very bad. Very bad. The kids from our class were on 3 different atoms. Swirling winds made atoms fly all around inside the cloud. We were lucky that the 3 atoms with us on them stayed together. They began to sink down in the cloud. Hey! Charlie's cry rang out from above us. What about me? Oops! None of us had noticed that Charlie had been left behind in our old atom. He orbited around the protons and the neutrons at the atom center. But while our atoms were moving downward, his was moving upward. D.A. clutched her weather book and stared at Charlie. He's got my notebook, she said, and he's moving further and further up. Poor Charlie. Now that he wasn't with Miss Frizzle anymore, how was he going to learn about weather? Why isn't Charlie's atom moving down with the rest of us? Tim asked. Looking up, I saw that Charlie's atom didn't have nearly as many electrons as it had had before. The other atoms rammed into it. I get it, I said. Charlie's atom has more protons than electrons, so it's positively charged, right? You said it, Miss Frizzle agreed. His atom is moving to the top of the thundercloud with all the other positively charged atoms. I looked at the three atoms around us, which the rest of us orbited. So our atoms, which have more electrons, are moving down to the bottom of the cloud, I said, which means we have a negative charge of static electricity, Tim finished. And then here we have another Q info note. Electrons throw their weight around by Ralphie. Electrons jump from one atom to another when water droplets, raindrops, and hailstones smash into one another. The warmest objects, like heavy raindrops and hailstones, collect the most electrons. These heavy objects fall to the lower part of the clouds, so most of the electrons are in the bottom of the cloud. It says, I guess when it comes to static electricity, said Carlos, being negative can really bring you down. Carlos, we all groaned again. Carlos is the king of bad jokes. But he was right about one thing. Our negativity charged atoms went down, down, down. Before long, we reached the bottom of the cloud. It was really crowded down there. More and more negatively charged atoms collected around us. Electrons jostled together, and we were right in the thick of it. The feeling was, well, it felt electric. Ralphie looked around in amazement. So this is what happens when static electricity builds up, he said. And here's another little cue card here. And it says, What makes electricity static? By Phoebe. We say something is static when it doesn't change or move. Static electricity is a kind of stored energy because the electrons are relatively emotionless. Static electricity cannot power appliances or release heat and light. By now, we had totally lost sight of Charlie. It was hard to even tell which way was up with all those negatively charged atoms around us. How were we ever going to find Charlie again? I didn't have much time to worry about that, though. Hey, I gulped as I felt a kind of pressure tugging at me from below. What's going on? Carlos looked around with his wide eyes. That's the megawatt question, Keisha, he said. Absolutely, the Frizz agreed, and we're about to learn the answer. Chapter 6. The next thing I knew, electrons all around us shot down from the bottom of the cloud, and we were pulled right along with them. We zoomed toward the earth in a tube-like channel. Bad, oh bad, oh bad, oh bad, oh bad. My heart leaped into the throat as we sped along. Miss Frizzle, yelped Ralphie, what's happening? Electricity is what's happening, Miss Frizzle announced. When the charge at the base of the cloud becomes strong enough, electricity energy is released. And here is a cue card, little info cue note. It says, if it's moving, it isn't static, by Keisha. When the electrons held in static electricity are pushed into motion, they create an active kind of energy called current electricity. Electric current goes with the flow as a current in a stream. As a flow of water, electric current is a flow of electrons. So that's a pretty cool thing. You mean we're electric energy? Arnold asked as we whooshed down from the clouds with the other electrons. You bet, the Frizz answered. We're an electric current. Is that what flows through the wires in your house? Asked Tim. Yes, but this current is stronger, a lot stronger, Miss Frizzle said. But now that we know we're a current, where are we going? Phoebe wanted to know. I think I can answer that, said D.A. She held up her weather book. It says in here that the negative electric charges at the bottom of the cloud are attracted to positive charges in the ground below. And we actually have 2 cue notes here. So it says, Opposites Attract by Wanda. Opposite electric charges, positive and negative, attract each other. Electric charges that are the same, positive and positive, or negative and negative, push away from each other. And a good rule to remember that or to know that by is with magnets, and how you will notice that sometimes when you try to put 2 magnets together, it won't go because that that negative and positive charge isn't there. And here's our second cue card. Lightning moves in steps. And this one's by Carlos. The stream of the electrons released from the bottom of the cumulonimbus cloud moves toward the ground. I struggle with that word. Ground in a series of strokes. This stream is called a steeped ladder. Each stroke lasts for just a fraction of a second, and it takes about 4 strokes for it's a stepped leader. Sorry, I was totally wrong with that. Stepped leader to reach the ground. That's fast. Okay, so I'm going to reread that again. The stream of the electrons released from the bottom of the cumulonimbus cloud moves toward the ground in a series of strokes. The stream is called a stepped leader. Each stroke lasts for just a fraction of a second, and it takes about 4 strokes for a stepped leader to reach the ground. That's fast. Y'all, I can't read today. Something's wrong with me. So, if what DA was saying was true, we were whizzing at lightning speed toward the ground. I've heard of kids being grounded, said Carlos, but this is ridiculous. Oh, why did we have to turn into electrons? Arnold asked, groaning. Let me tell you, we weren't just moving. We went like a streak. Zip, zoom, zing. We zigzagged down towards the earth in strokes that followed each other so quickly I couldn't keep track of them. And every zig and zag took us further away from Charlie Nimbus. Uh-oh. So we have little cue card. And it says, see that crooked lightning? By D.A. Ever wondered why lightning is so jagged? It's because a stepped leader doesn't move in a straight line. It makes a crooked zigzag path down from the cloud. I never knew that either. That's pretty cool. Okay. I see the ground, Tim announced. Somehow I made myself look down. Sure enough, the leafy tops of the trees were there below us. Thanks to my special goggles, I saw something else too. A stream of positive electric charges that jumped towards us from the highest treetop. How marvelous, said the Frizz. That streamer is coming up to meet us, right on schedule. And then we have another little cue card here. It says, as a stepped leader nears the ground, it can create a pull so strong that the positive atoms in the ground rise to meet it. This channel of positively charged atoms is called a streamer. A streamer often forms, but not always. Marvelous is not exactly the word I'd use, said Arnold. More like terrifying. That streamer sure seemed eager to get to us. It jumped straight towards us from the top of that tree. And then we got contact, cried Miss Frizzle. At that moment, the stepped leader and the streamer meet. I shut my eyes. This was too much. Way too much. Uh-oh, I heard Carla say. Get ready for an electrifying ride. And then we have another cue note. And then we have a picture here. So you can see what they were talking about. Okay. The cue note says, Lightning You Can See by Phoebe. When we see a bolt of lightning, we're not seeing stepped leaders, and streamers. They are not visible. The lightning we see forms only after the negative stepped leader makes contact with the positive atoms in the ground. And then the thought bubble that was on this picture that I showed you, you can see that this is certainly a current event. So that was the end of chapter 6. And so next time we will start with chapter 7. And I hope you guys are enjoying this book because I know I am learning a lot about thunderstorms, actually water, hail, electric, everything. It's pretty cool stuff to know. So I hope you guys are enjoying it and tune in next time and we will finish the book. Thanks guys. Have a great day.